Hello, everyone. Welcome to the lab session on the smoothing averages, including the simple moving average and the exponential moving average. So let's get started. Firstly, here we download the stock data for Apple for this range. So for the first dates of January in 2022 to the beginning of 2023. Now, after downloading the data using Y Finance, we then convert the index to a datetime format like this. So this is the index, and then we have as usual, the open, high, low, close, adjusted close, and volume data here. Now we focus on the adjusted close column and then plot it out. So here's the plot. I'm just skipping the plotting codes, but you see that here it is smart enough to identify the index as a month, so it's aggregated to a monthly level. So that's the purpose of converting the index to a datetime format, so that it's smart enough to be able to identify the dates and aggregate up to a monthly level. So this is the adjusted closing price of Apple. Now let's look at how to calculate the simple moving average. So let me just change it here, simple moving average. All right. So the way it works is, as we covered earlier, by first specifying a window. So the window size in this case is 3, which means that for the new column, which is called the SME3, and I'm creating a variable, we just hold the name of the variable, right? So based on the window size I set, and then creating this column. So this is column I'm creating. So by specifying a window size of 3, each value in the new column will be a result of averaging 3 values. So these 3 values comes from the corresponding values for the same row, and plus the previous 2 values. So in this case, I'm looking at the resulting value of this quantity. This comes from by averaging the 3 quantities, 1, 2, 3, right? So which means that implementation wise, we're first rolling the window. So this means that for each value here, I'm just imagine there's a window that's actually capturing these 3 values, including the count value, right? And then taking the mean of the 3 values. So that's how it's been calculated. Of course, the first 2 values are null because there's no previous values before the first value here. And then I'm just selecting the columns I'm interested in, and I pass it to data frame, and visualizing the results. All right, so that's how we calculate the simple moving average. All right, so by using the rolling function. We can do a bit of verification by looking at the first 3 values, right? So meaning I'm taking this adjusted close column, take the first 3 values, and then calculate the mean value, which is the same value as the value here, right? So that verifies our calculation earlier. Then the problem is for the first 2 values, it's not usable, right? So for the follow-up calculations, they are so they are not usable. However, if I want to still use them, right, by sort of ignoring the requirements of the window size of 3, so this can be done by setting the mean periods to 1. So what this means that as long as there's at least 1 value in the window, then I can use it. So in this case, if it's the first value, then the average value of the quantity is still the self, right? So see the result here is still the self. And for this guy, so in this case, the window has only 2 values, right? 2 values, then this result is the average of these 2 quantities. So that's the use of the mean periods here. And we can plot it out in terms of the resulting smoothing averages. So here I'm plotting the window size of 3. Let's say red line here is tracking the original adjusted close price very closely because the window size only 3, right? So there's still a lot of ups and downs. However, if we set the window size to 20, then suddenly the line becomes much smoother. And the reason is because each value is a result of averaging the past 20 values, right? So that's actually alleviating a lot of ups and downs, and that gives you a much smoother curve. So this is SMA 20. All right, so let's come to the exponential moving average. Again, so the way it works is we are specifying an alpha a parameter here. So there's no explicit setting of the window size. Alpha means that this is the weight we assign to the current value, right? So it's we talked about earlier. It is a trade-off, right? It is a combination between the current value and the historical running averages, running exponential moving average, right? So implementation-wise, we are using the EWM, exponentially weighted moving average function, by specifying the alpha and the adjustment is false. So this function has multiple parameters which you can specify, but to exactly mimic the setting we covered in the previous lecture in terms of calculating the exponential moving average, then this is the way to set it. So we set alpha to 0.1 and then take the average. So the net result is here. As we mentioned earlier, there's no NA because we'll use all the historical data points, right? All the historical data points. The only thing is the more we go further into the future, the further we go down, then the width for the previous values, right? Width for the previous values, it's gonna decrease exponentially, right? So that's the exponential weight curve. Now let's again do a bit of verification. So here I'm setting alpha equals to 0.1, and then so this is a value I calculated, so 0.1, and I'm just going to take this value, which is just close one, and multiply alpha, right? And then the previous value, which is the first value, right? First value, and multiply by 1 minus alpha. This gives me the 180.73, right? 180.73 is how I calculated this value here. All right, so that's verifies our calculation by putting the alpha weight to the current value. And we can also adjust this parameter to produce a different weighting scale. So in this case, 50% goes to the current value, and another 50% goes to the historical moving averages. Right? And then I'm just using the same methods here, and I have another series. So let's plot all the series together, and you see that different specifications of the parameters results in different smooth curves. Right? So in this case, the EWM 0.5 is the purple line here, which is again tracking closely to the adjusted close here. So the result is that these lines are very different in terms of the weighting scale, and that gives you a different smooth curve. And these curves will again come into the later strategy formulation part, where we are taking two smooth curves, and then say if there's a crossover, then we can generate a trading signal and make a trading action accordingly. So that's it for this video, and thanks for watching.